Hello everyone. In this lecture, I will be explaining synchronous motor drive. It's basically a synchronous motor drive is a system that control the speed and operation of that synchronous motor by controlling that frequency and voltage. So let's first see the basic operation of synchronous motor. That in a speed of the synchronous motor depend on the supply frequency. So as we know that synchronous speed ns equal to 120 f by p, where f is the frequency, this ns is the synchronous speed, and p is the number of pole. Now by varying this frequency, we can vary the speed. So in the earlier days, there is no variable frequency sources available. So that's why it's very difficult to vary the frequency. So as we cannot vary the frequency, so we cannot vary the speed of that synchronous motors. So nowadays we are designed so many like power electronics converters like rectifier, inverter, even cycloconverter is there. So by using that, we can easily vary the frequency and voltage. So by varying this voltage and frequency, we can easily control the speed of synchronous motor. So as we control the speed of that synchronous motor, so we can operate this synchronous speed for various types of applications. Now see the characteristics of the synchronous motor. So that's characteristics of the synchronous motor is it runs only in synchronous speed and it is not self-starting. To start that synchronous motor initially, with the rotor some exciter is DC exciter is connected, and it can operate in lagging power factor, unity power factor, and leading power factor. So these are the characteristics of that synchronous motor. Now in adjustable speed control, so as we have designed nowadays, we have designed different power electronics converters. So we use this for that variable frequency drives. Means by varying that frequency, we can control the speed. So according to the speed, we can use this synchronous motor for different types of applications. Now for here that supply frequency is varied, even voltage also varied to maintain the VYF ratio constant. So here our main aim is to maintain the VYF ratio constant. So that is voltage and frequency, voltage and frequency constant. So that is our main aim. Now that this VYF control principle is like maintain VYF constant. So in that case, flux remains constant and stable operation will be there. So why it is flux? As we know that phi is equal to VYF. So as we maintain this, if we are suppose we are increasing that voltage, in that case we need to increase the frequency. Now in the other case, suppose voltage is decreasing, so in that case we need to decrease the frequency also. Then we can make the flux remains constant. So that if we do like that, so in that case stable motor operation is possible. Now there are different types of control is there to control the speed of that synchronous motor. So there are different mechanism, or we can say that there are different system is there. So by which we can control the, or we can drive the motor. So there is a open loop synchronous drive. So in the and another one is the closed loop. So I will talk about closed loop later. So first we will see that open loop synchronous motor drive. So there first if we connect that synchronous motor with the supply. So if we connect this synchronous motor directly with the supply, so in that case our frequency will be fixed. Even voltage will be fixed. If both the voltage and frequency will be fixed, so in that case we cannot control the speed of this synchronous motor. So that's why, so there is some components we have connected in between this supply and this synchronous motor. So that is rectifier and PWM inverter. So this is a power electronics converter, that rectifier and inverter. So by connecting that rectifier, it is converting AC to DC. Again, by using this inverter, this DC is converting to AC. So that I will explain later, like why we are converting first this AC to DC. Again we are converting DC to AC, and that is used for the controlling speed of that induction motor, synchronous motor. So let's elaborately we understand what is this VYF control. So VYF control is that is open loop VYF control. So that is mostly used for that controlling the speed of induction motor also and synchronous motor also. So by connecting some power electronics converters, that may be a inverter, that may be a rectifier, or that may be a cycloconverter. So the basic principle is to control the stator voltage and frequency simultaneously, so that the ratio of that V by F remains constant. Just maintain this ratio, that the air gap magnetic flux of the rotor remains constant, which is necessary for the proper motor operation. Means if we are how we are maintaining, if we increase the voltage, then we need to increase the frequency. If we are decreasing that voltage, we need to decrease the frequency. In this way we can maintain the ratio, and this method is widely used in variable frequency drives, VFD, for applications like pumps, fans, compressor, and conveyor belts. So these are the application of these variable frequency drives. Now let's understand that VYF control, basics of VYF control. So the induced EMF equation, or we can say that induction motor, so that we can synchronous motor, we can write that E is equal to 4.44 F N phi, where E is the induced EMF, F is the frequency, and N is the number of turns, and phi is the magnetic flux. Now if we rearrange, so in that case we can write phi is equal to V by F. So thus this V by F, we should make it constant, because so that what is the meaning of that? Meaning is that if frequency decrease, that must be that voltage should be decreased. Suppose now that initially that is V by F. Now if voltage is 0. That is V by 2. So in that case, that what will be the frequency? That frequency also F by 2. Now if we, in the second case, if frequency is increased, then voltage also must be increased. So that is means if now V is 2V, then frequency should be 2V. So in this way, if we increase or decrease proportionally, then only we can make this V by F constant. Then there will be a smooth operation is there. So this keeps the motor flux constant and preventing magnetic saturation if voltage is too high. So that I will explain what is this, how there will be magnetic saturation. And if too weak, in that case the voltage is too low, that motor can stop. So this is the like basic principle of that V by F control. Now let's understand that open loop block diagram of that synchronous motor drive. So this is the block diagram, open loop diagram of a synchronous motor drive, where different components are connected, like three-phase AC supply. So what that we know that what is AC single phase or three-phase supply. So that may be 230 volt or 415 volt. So in case of that single phase and three phase, so this is the line to neutral voltage, that is 230 volt and 415 volt. This AC supply cannot directly control the speed, as here voltage is fixed, even frequency is also fixed. So that's why by using these we cannot control the speed. So therefore we need what? We need power electronics converter. So we need power electronics converters. So power electronics converters means that rectifier inverter set or cycloconverter. Okay, let's move to the second component. So that is rectifier. So what is rectifier? So basically we know that rectifier is simply it's convert that AC to DC. So here, as to control, as we have connected to a three-phase AC supply. So that's why we have convert. First it convert to, by using that rectifier we are converting AC to DC. Now there are different types of rectifier is there. So maybe in the diode rectifier. So diode rectifier is you can say that is an uncontrolled rectifier. Means as diode is an uncontrolled switch, so whatever rectifier we are making, so that is an uncontrolled rectifier. Now next one is the thyristor rectifier. Now we know that thyristor is a semi-controlled switch. So in a semi-controlled switch means that we can control like any one state. So that's why this is a like semi-controlled rectifier. And if we use MOSFET, now in case of that controlled rectifier, like fully controlled, so we need MOSFET. We need MOSFET or IGBT. So if we use these two devices, so in that case we can say this is a fully controlled device, as these two devices are fully controlled switch. So main purpose of these switches is to provide DC output for the inverter stage. Now that after that these supplies go to the inverter stage, but before that there is another section that is called DC link. So what is the use of this inductor and capacitor here, that I will be explaining. So here we have connected one inductor and another one is the capacitor. So that is in between this inverter and rectifier set. So what is the main purpose of this? So that main purpose of this is, as when we are converting this AC supply to a DC by using a rectifier, that may be some ripple. So there is no maybe so for making it to remove that ripple or smooth the DC, or for sometimes for the storage systems we are using this inductor and capacitor. So it's provide a stable DC supply for the, means it generates a stable DC supply for the inverter input. Now move to the next component. So that is the function generator. So basically that what is the main purpose of that function generator is, it's provide the speed reference, means for which speed that inverter will generate the signal. So that is given by this function generator. So that is providing the reference speed. So the function generator generates the reference signal for the inverter. So in the input, basically it is command speed for the operator or controller. So in the output, what we are getting that voltage reference and frequency reference. So thus it determines speed proportional to the frequency. Speed proportional means whatever. So according to that frequency, we are controlling the speed. So whatever, so that is the ratio, means if we are based on that frequency, we are getting that, or we can varying the speed of that synchronous motor. Now the next is the PWM inverter. So this is the main component of this, like this block or open loop system. So there is a, so we know that PWM converter is that pulse width modulation inverter. So basically by this pulse width modulation, what we are doing, we are varying the frequency and voltage. As we know that for controlling the speed of that synchronous motor, we need variable frequency and variable voltage. So that is generating by using this PWM inverter. So this DC to AC inverter use power electronic switches, like different switches like IGBT, fully controlled switch. This is MOSFET also, then GTO and thyristor. So it is using all these switches to controlling or to varying the frequency and voltage. So the inverter produce pulse width modulation AC waveforms, and main function is generate the three-phase AC output, then the controlled frequency and controlled voltage to control the speed of that synchronous motor. Now after that last block, it is that motor load. So the output of that inverter is supplied to the, like different types of motor, maybe the induction motor, maybe the synchronous motor. So we know that motor speed is determined by, that is Ns equal to 120 F by P, where N is the synchronous speed, F is the frequency, and P is the number of poles. So as in the here it is F is there. So if we vary the frequency, so we can control the speed. So that's why we are varying the frequency. Thus speed is controlled by frequency. Now if we just see the two operation or two condition in the case one, suppose now we are increasing frequency. So what will be the command? So function generator generate that increasing frequency. So in that case, what will happen? Voltage, we need to increase the voltage also. Like as we know that phi proportional to V by F. So as voltage is increasing, voltage as the frequency is increased. Now frequency is increased. To make it constant, we need to increase the voltage also. So we need to increase the voltage also, so that V by F ratio remains constant and motor speed will increase. So we can say that motor accelerates smoothly. Now in the second case, when frequency is decreasing, now that phi is proportional to V by F. Now suppose frequency is increasing. Now if we increase the voltage, so in that case that ratio will not be maintained. So that's why what we need to do, we need to decrease the voltage. So in that case we can maintain the V by F ratio constant. So here what will happen? Motor speed will decrease, and we can say that motor deaccelerates smoothly. Now why V by F must be constant? So that if V by F is not maintained constant, so what will be the problem? Now if there is a voltage is too high, so every magnet, it has some capacity, so that after that if we are increase the supply, that what will happen? It will saturates. So then there will be by flowing that supply also, that it magnetic property will not increase. But what will happen if we increase the voltage? What will happen? There will be excessive heating. It will heat up, maybe it will damage that magnet, and there will be a huge amount of core losses increase. So this is the disadvantage of too high voltage. Now in case of that too low voltage, what will happen? Flux decrease. Flux decreases, that amount of flux will not generate, that weak magnetic flux effect reduce the torques, and motor may stop. So this is the condition when that voltage is too high and that when voltage is too low. Now this open loops, we know that as it is a open loop system, so there is no feedback from the motor speed. So means we are not taking the feedback by using that sensor, speed sensor from the motor. So the controller assumes that motor follows the command speed only, means which is generating by a function generator, which is generating by a function generator. So that command is generating by a function generator. So now therefore command speed to the inverter, so that command speed is generating by the function generator and it is giving to the inverter, then inverter, according to that inverter control, that motor speed is controlling, but that actual speed is not measured. So if when we are using this open loop control, now in the next will in the upcoming lecture I will be explaining that closed loop control. So there we need to take that feedback from that motor speed, and accordingly the controller will controlling the speed of that motor. Now we'll see the advantage and disadvantage. So it is very simple, as it is an open loop system. So in the open loop system there is we need to connect less components also. So if there is less components, means that simple in circuit is also simple and simple control method is there. So as less component is used, so cost is also low and easy implementation, suitable for the many industrial drives, smooth speed control. And disadvantage is no speed feedback. So in that case, what will be, accuracy is little bit lower and torque control is limited, not suitable for the high performance drive. Now we'll see in the application, like where that accuracy is little bit means we cannot that much accuracy is not required. So in that type of drive we can use this open loop control. Like open loop feedback control is mainly used in that pumps, fans, blowers, compressors, conveyor belts, HVDC systems. So what all these systems are, means here if we don't maintain that precise control, so that is also okay. So that's why we can use this open loop control in this type of drive only. So this application do not require any precise speed control. Okay, that's all about this open loop control and this introduction of that synchronous motor drives. So in the next lecture I will be explaining that closed loop control of synchronous motor drive. Okay, thank you.